Hi, it's Callum. We're going to talk about lymph nodes in this video. So you're going to come across lymph nodes in two main settings. Within hematopathology, we look at lymph nodes very closely, and that is primarily for the diagnosis of lymphoma or other hematopathological conditions. And H&E is important, but it needs backed up with panels, large panels, sometimes multiple panels of immunohistochemistry. And it's very complex and specialized. However, the majority of the time you will be dealing with lymph nodes as part of your surgical practice, and that's when dealing with carcinomas, and you're looking at lymph nodes to see if the carcinoma has spread to the lymph nodes. In those circumstances, the details of the lymph node architecture, etc., is probably going to be less important, and really what you're doing is screening the lymph nodes quickly to look to see if they've been involved with carcinoma. So this video, we're going to have a quick overview of lymph node histology and architecture. So we've got a fully excised lymph node here. Unfortunately, not a very good section through it, but we'll deal with what we've got. So ignore this middle bit here, which is something else. This is one half of the lymph node, and this is the other half of the lymph node. And imagine these were, if you could close these like a book, this bit would fit on top of this. So these are the same two halves of the same lymph node. So lymph nodes, if you get a good section, will have a slightly kidney bean architecture. I think we can demonstrate that here. It just looks slightly curved with a hilum in the center here. And we can see that here, slightly kidney bean architecture, with a centrally indented with a kind of hilum here. The architecture of a lymph node, we've got I should say, this is surrounded in just adipose tissue and fat with some blood vessels. The architecture of a lymph node is that you will sometimes see your lymphatics coming in to introduce a lymph, which has been drained from the tissue, into the lymph node. And then you might also see the kind of lymphatic leading away, the efferent lymphatic leading away from the hilum. I don't think we can really see that here. But if we start from the outside and work in, the outside of the lymph node, it's an encapsulated structure. It's got a capsule. By definition, it must have a capsule. And so if we look closely, we can maybe see that. That should just be a thin rim of connective tissue that runs around the outside. I think that's what we've got here. Of connective tissue. It's quite thin. I think it's definitely there. Yeah, quite easy to see in this area. You've got the thin rim of connective tissue. Underneath the capsule, you should have a sinus. So it's an empty space. So here's we call that the subcapsular sinus. And here's, you can demonstrate that here quite easily. So we've got an empty space, which is filled with cells. And the cells that fill that space are the sinus histiocytes. So these are histiocytes. So these are parts of the monophage, the monocyte macrophage lineage, cells with round to ovoid nuclei, an abundant eosinophilic cytoplasm. It's often fluffy. So these are the sinus histiocytes, and that's the subcapsular sinus. That is the first port of call for draining lymph that's draining through the lymphatics into the node. So if you're looking for carcinoma, if this is a lymph node that's draining a known carcinoma, the subcapsular sinus is a really good first place to look. If it isn't obvious that the carcinoma is within the lymph node, go down around the subcapsular sinus and ×10 magnification to see if you can find any small aggregates of carcinoma. Anyway, it's an aside. So we've got the capsule, subcapsular sinus, and the next part is the cortex. So we've got the cortex goes around the outside, a bit like in a kidney. The cortex is on the outside, and the medulla is in the center. The medulla is not very easily represented. It's actually not easy to show in this section particularly, but the medulla is made of, it's kind of got sinuses and medullary cords. And there's not much to really see other than that anyway. So the main points I'm going to be able to illustrate from the lymph node are in the cortex anyway. So you can see at low power, the cortex is not just an architecturalist mass of cells. We've got these aggregates, these round aggregates of cells. These are all aggregates of lymphoid cells, which are only found in the cortex, and these are the follicles. There are two types of follicles within lymph nodes. There are the primary follicles, which is like this one, which is just a mass of blue lymphoid cells, which are inactivated. And then there are the secondary follicles, which has got the same cells, the same mass of inactivated cells, but in the center of it, there is what we call a germinal center, which looks quite different from the inactivated cells around about it. Cells within the germinal center are activated, they're replicating, and we're going to go into that in a second. But you can see, I think it's quite obvious. Here's a germinal center, here's a germinal center, here's a germinal center, here's one, here's a big one. And so if a lymphoid follicle has a germinal center, it's a secondary follicle. And if it doesn't have one, it's a primary follicle. So the cortex of the lymph node is the domain of B lymphocytes. So the cortex basically, essentially, is made of B lymphocytes. Whereas the sinus is just macrophages or histiocytes. There is a paracortex or a paracortical zone where which is the domain of T lymphocytes, but pointing that out here is quite difficult. This is maybe paracortical T cells here, but I can't be sure of that. You would need to do immunohistochemistry to point that out, I think, with any accuracy. And then within the medulla, which we can't really prove here, but you will see plasma cells. So let's look at the germinal center to see if we can cover that in a bit more detail. Here we are. Here's a good one to show you. Okay, so within a germinal center, there should be, and it's not always easy to show, but there should be a dark half and a light half. So if this is the germinal center that I'm outlining here, it's a bit subtle, but if we draw a line down here, everything on this side of the line is the dark half. Everything on this side of the line is the light half. Hopefully you can sort of see it's a bit subtle. And if you start looking around on your own when you see lymph nodes, you might be able to see less subtle examples, but it often can be a wee bit subtle. And that's because there are two main areas here with different cells in them. So as I said, the germinal center is made of activated B lymphoid cells. So within the dark half, we've mostly got centroblasts. So these are large, I'm just pointing at the nuclei here. The cytoplasm is quite difficult and indistinct, but the large hematoxylin staining nuclei are bigger than if you compare them to the inactivated B cells around about them here. Within the germinal center, they're large, and they've also got these big nucleoli, big slightly red structures within the nucleoli, within the nuclei, or nucleoli, this one. So these, if you see these big nuclei within the germinal center with nucleoli in them, these are likely centroblasts, activated B cells. Within the other half are centrocytes, and these are much smaller cells that are often elongated and so notched. They have a notch taken out of them. You imagine here as though someone's taken a bite out of this apple. There's a notch out of the center of it. Here's another one, sometimes called cleaved. These cells are sometimes, that's sometimes another word we give for that, where you can see there's just been a chunk taken out of it, and that's what a centrocyte looks like. Often they look a bit longer than they are wide, and that's a centrocyte. So we've got centrocytes on this half, centroblasts in this half for the most part, and we will also see, let's see if we can find a better example. Here, oh, this is good. We also have another cell type. Now these cells are replicating really quickly. These are all being activated and they're mitotically active. But when the cells are mitotically active, very active, often there is mistakes happen. And if mistakes in replication have been identified, the cells undergo programmed cell death or apoptosis. And the debris then needs mopped up. And that's what these cells are doing. So these are tingible body macrophages. That's one, that's another one, that's another one. So this is the outline of the cytoplasm. That's the nucleus there. And within the cytoplasm, there is this is debris. It's nuclear debris, and that's dead bits of B lymphoid cells, hoovered up by these phagocytic cells called tingible body macrophages. There are also antigen-presenting cells within all of this, but I'm not very good at, to be honest, identifying them. But these are called follicular dendritic cells. You can identify them, you can highlight them with immunohistochemistry, as you can with all of these other cells. But it'd be far be it from me to be able to identify what in here is a follicular dendritic cell and what is what are the other cells. But they are the antigen-presenting cells. They're modified they're like histiocyte-like cells. So that's the germinal center, and these are follicles. So these are all secondary follicles. So at the surrounding the follicles, there are these collections of inactivated B lymphocytes, and they form the mantle zone. And they're around all of these. You can almost line up in rows here. These form the mantle zones. So we've got the germinal centers of secondary follicles, the primary follicles surrounded by mantle zones of inactivated B cells. And at the very, very edge, there's also a marginal zone. However, you need immunohistochemistry to pick that out. I don't know where the mantle zone. I don't think it's impossible. I don't think it's possible on H&E to tell where the marginal zone stops and the mantle zone begins. But that's that they are the different, and then there's the paracortical or the paracortex with T cells in it, and that's a kind of beginner's guide to lymph node architecture. And there's lots to talk about within lymph nodes, a lot more than what I have gone through here. But I think this is just, it'll do you for an introduction. And if you want more information, approach your friendly hematopathologist. Okay, speak to you soon.